Welcome back once again, everybody. It's Mr. Grosso. The third transformation that we're going to take a look at today is dilation. All right, dilation or to dilate something means to make it bigger or smaller. So we're going to take the shapes that you guys have started off with, either make them bigger or make them smaller. All right, if this sounds familiar, all right, very well could be. Anybody who has gone to the eye doctors or had some kind of eye exam, all right, you have had your eyes dilated by the doctor. All right, the pupils in your eyes, the little black parts, they get bigger or smaller reacting to how much light is actually in the room. All right, so that's a little experiment that you guys can actually do. If you go into a dark room, all right, you could probably do it in a bathroom because the bathroom's going to have a mirror for you. So if you turn the lights off in the bathroom, give your eyes a few seconds to adjust to the lack of light, and then you turn the switch on and turn the lights on, you will see your pupils shrink up because there's more light than there was before, so your eyes have to work less hard to search for the light. So just a little experiment that you guys could do. All right, let's take a look here. Once again, since this is a new transformation, we're kind of changing up the colors a little bit. So since it's going to be dilate or dilation, we're going to make that green, so the points this time are going to be green. But everything else is the same. You have a 3 or 4 point original shape. You got the original coordinates over here. You have your little key over here telling you how to work with the coordinates. And then you have everything you're responsible for over here. You got your points, you got your coordinates that you got to fill in, and then you have your directions. All right, this one for dilation, our approach is going to be a little bit different than what it has been for the past two transformations. What we did before was we moved the points first and then got the coordinates. This time, we're going to get the coordinates first and then move the points. Since we're making the shapes bigger or smaller, it's a lot more coordinate and numerical based. So it's going to be a little different, but a little bit easier too. So if we take a look at the directions here, we're going to dilate the given shape times 2, all right, which means we're going to multiply it times 2, and then fill in the new coordinates. So what we're going to do is we're actually going to do the coordinates first and then do the points. So if you take a look up here, we're going to use all those original points and multiply them by 2, and that's going to give us all of our new coordinates. All right, so let's start with A. We're going to multiply A's coordinates by 2. All right, so we'll do 1 times 2 is 2. So A prime's first number is going to be 2. All right, let's go back up here. This one's going to be times 2. So 2 times 2 is 4. That's going to be this number right here. And now that we have these coordinates, now we can put A prime where it's supposed to be. So we'll grab A prime, bring it over here. 2, 4 is going to be right there. So that's where A prime is going to go. All right, this time we're going to do B and get B prime's coordinates. So taking a look at B, we're going to multiply those two numbers times 2, and that'll give us B prime's 2 numbers. All right, so B's x-coordinate is 2, so we'll multiply that by 2 and get 4 for this one. All right, let's go back up here. For the y-coordinate here, 5 times 2 is going to be 10, so 10 is going to be B prime's y-coordinate. So now that we have those two coordinates, we'll grab B prime. Let's see, it's 4 tenths, so we got to go over 4. And up 10 is all the way up to the top. This is a 10 by 10 grid, so anytime you get 10 or negative 10, it'll be right there on that edge. All right, this time let's do C prime. So we need to look at C's points. All right, multiply 4 times 2. That'll give us 8. I'm going to go back up here. 3 times 2, that'll give us 6. And those are the coordinates for C prime. So we'll grab C prime here. We'll go over 8 and then up 6. We'll be right there. All right, and then lastly, let's do D prime. So we'll take a look at D's points here. So we're going to multiply 3 by 2. That's going to give us 6 for this spot. All right, and then 0 times 2, 0 times anything is going to be 0. So we'll grab d prime. All right, 6, 0. That means we're going to move 6 in the right, but we're not going to go up or down at all because that coordinate is 0. So we'll go over 6, but not up or down at all. So it's going to be right there. All right, and again, you guys are not responsible, nor should you connect these points, but I'm just going to show you that we took the original shape right here and magnified it times 2, so it's twice as big. So the length of this side right here is twice as long. All right, everything is multiplied it by 2. All right, so let's take a look at another bigger example. All right, this guy right here. Now, if you notice, this is the first time we've had a shape with like all 4 points in different quadrants, but it's all right, we're still doing the same exact thing here. This time we're going to dilate the given shape by 3. So we're going to multiply it 3 times, all of these numbers right here. So start with A. So 2 times 3 is going to be 6. So that means this number is going to be 6. Come back up here. 1 times 3 is going to be 3. So this number should be 3. So A prime's coordinates are going to be 6, 3. So let's grab A prime's. Let's grab it over here. And it's going to go 6, 3. So over 6, up 1, 2, 3. Should be right there. Now, since it's going to be 3 times bigger, it's going to look massive when you compare it to the original. All right, let's take a look at B here. B's got a -2. So -2 times 3 is going to be -6. And then back up here for this one, 3 times 3 is going to be 9, and that's exactly what we're going to have here. So -6, +9 is where we're going to put B prime. -6, +9 should be all the way up here. There you go, halfway through. All right, let's take a look at C's coordinates. So we got -3 and -3. All right, -3 times 3. A negative times a positive is going to be a negative, so that's going to be a -9. And it's the same exact thing for this one. -3 times 3, -9. So let's grab C prime. Go over -9 and then down -9, be right there. All right, and then let's take a look at D. 1 times 3 is going to be 3 for this coordinate. And then -2 times 3, all right, negative times a positive, -6. So, whoops, forgot to grab D prime here. All right, so that's +3, and then -6 will be right there. Now, again, if we connect it, you can kind of get a little bit better of a visual of how much bigger, all right? It's 3 times bigger than the original shape right here. So if you were to measure out this side right here, all right, let's say that that's, I don't know, 2 units long. This one right here would be 6 units long. All right, everything is 3 times bigger than the original. All right, so these were just 2 examples of making shapes bigger. So you guys are going to work on the next 2 problems that are also making shapes bigger. And then I'll meet you at the video explaining how you're making shapes smaller, and we'll go from there. All right, everybody, good luck on the next 2 problems. I'll see you at the next video.